What was the Earth like before the dinosaurs? Bring your curiosity and let's go on a journey together. Let's fast forward 5 billion years. The earliest epoch of Earth, the Azoic era, is a seldom mentioned geological age because it was an era of deathly stillness that lasted for 4 billion years. 13.8 billion years ago, the diffused gases and particles in the solar system underwent billions of years of contraction. Amid the constant collision and condensation of planetesimals, the Earth was finally born 4.6 billion years ago, beginning its long evolution. The Precambrian, also known as the Cryptozoic Eon, had its first stage called the Eoarchean era, which lasted for 600 million years. At that time, the Earth was like a purgatory, a fireball. 4.53 billion years ago, a planet named Theia collided with the Earth. The debris from the collision formed a ring of rock around the Earth. Through accretion, the Moon was born. In the 100 million years that followed, the Earth gradually cooled. Iron atoms and heavy minerals began to sink, forming the Earth's core. After 400 million years of long evolution, the mantle and crust also gradually formed. The crust was still very thin, and volcanic eruptions on Earth were frequent. Accompanied by collisions from asteroids and comets, the Earth sighed in the abyss. But the volcanic eruptions and collisions brought a large amount of water. When the moisture in the atmosphere reached saturation, rain formed. However, the surface temperature was extremely high, causing the rainwater to evaporate and return to the atmosphere in a cycle. One great rain lasted for millions of years, and finally 4.1 billion years ago, the Archean Eon began, lasting for 1.5 billion years. The Earth was ready to be a great mother, welcoming the arrival of primitive life. 3.8 billion years ago, the oceans formed. Lava from volcanic eruptions slowly cooled, forming islands that gradually connected and formed stable cratons. Under the action of lightning and cosmic rays, organic compounds began to appear on Earth. Amino acids started to polymerize into proteins and nucleic acids. The earliest life on Earth, prokaryotes, was born. These siliceous stromatolites are the evidence of their existence. The evolution of life was slow, simple, and boring. After more than 1 billion years of development, prokaryotes were still prokaryotes. Finally, a groundbreaking era arrived. 2.5 billion years ago, during the Proterozoic Eon, which lasted for 2 billion years, the prokaryotic cyanobacteria used photosynthesis to transform the Earth into a blue planet. This event is historically known as the Great Oxidation Event. A large amount of oxygen reacted with free iron ions, precipitating to the seabed and forming the global iron ore deposits known as the banded iron formations. This period is called the Siderean period. However, a large amount of greenhouse gases in the atmosphere were consumed, and the Earth's temperature dropped drastically. 2.4 billion years ago, the Earth froze into a snowball. This is known as the Huronian glaciation. The night always comes before the dawn. 630 million years ago, the oxygen content in the atmosphere finally stabilized. Something beautiful happened unexpectedly. One playful cell entered another cell. They fused together and gradually evolved into eukaryotes. From 2 billion to 700 million years, there was not much progress in life's evolution. What's worse, the Earth ushered in another major catastrophe, the Snowball Earth event. This was the largest ice age to date, trapping the Earth for 100 million years. Perhaps the imprisoned life found a way out. 630 million years ago, the Ediacaran biota began. In China, it is called the Sinian period. Eukaryotes achieved an explosive development. The ocean at this time was a friendly world. There were no life or death battles and no predatory massacres. The Charnia was attached tightly to the seabed, like a cluster of plant leaves without the ability to move, or even a mouth and an anus. The Dickinsonia was round and flat, like a circular rug, only a few millimeters thick. The trilobite was a bizarre creature with 3 symmetrical parts spiraling out from the center of its body. There is no clear explanation of how these simple animals fed or reproduced, but they set go, making life's next steps full of unknown and discoveries.
The first light of life was brief. In the late Ediacaran, 540 million years ago, animals that accidentally obtained shells beat the soft-bodied animals without a fight. They stepped on the remains of the Ediacaran animals and continued forward, about to usher in the Cambrian explosion. The Cambrian explosion, the beginning of the Phanerozoic Eon, officially opened the curtain. Fossils of numerous phyla suddenly appeared in the strata, as if they were otherworldly immortals. It all began 540 million years ago. The Cambrian Ocean was unprecedented. The first ocean overlord, the Anomalocaris, hunted without restraint. The Opabinia, with 5 eyes and a long snout, searched for prey. The Morella waited for its chance to act. A few hallucigenia walked leisurely. The Wiwaxia, covered in spines, lay low on the seabed, plain dead. The Morella and pangaea trembled in fear. These ugly-looking creatures are actually the ancestors of modern animals. In the early 20th century, geologists believed that the appearance of a large number of fossils in the Cambrian was caused by the missing strata from the Precambrian. It wasn't until 1948 that paleontologist Glauert proposed the Cambrian explosion hypothesis, and it was widely accepted. The Cambrian was the domain of arthropods. All living things evolved with powerful skeletons. The rigid shells provided support for the muscles. Top predators roamed the ocean. Weak animals evolved armor, and some simply made themselves thin to be unappetizing. The Anomalocaris was the undisputed bug of the Cambrian. It could reach up to 2 meters in length and used the abdominal fins on both sides of its body to undulate through the water. It had a pair of gigantic, ping-pong ball-sized compound eyes. The huge mouth was like a disc composed of 32 overlapping sucking discs with a ring of sharp teeth in the center. A pair of huge claws in front of its mouth like a harpoon could easily pierce its prey. The sharp teeth tore the food to shreds. The extremely ugly Anomalocaris had thousands of variations, looking like this, and this. They were the first undisputed overlords of the ocean. Besides the overlord Anomalocaris, the trilobite crossed time for 300 million years, appearing in the Cambrian and going extinct in the Permian, outlasting one generation of ocean overlords after another and successfully giving the world an unyielding middle finger. Most trilobites were oval-shaped, 3 to 10 centimeters in length, with the longest reaching up to 70 centimeters. The body was divided into 3 parts: head, thorax, and abdomen. The back was covered with a strong carapace divided into 3 liquid parts. Each body undergoes multiple molts in development to grow. Some species even have thousands of compound eyes. The thorax is composed of movable segments that can bend. It mainly feeds on the carcasses of soft-bodied animals, seaweed, and other small creatures. Trilobites are an important basis for dividing strata of the Paleozoic era and are first-hand data for studying paleogeography and paleoenvironments. Look at this Opabinia. It had 5 eyes and a mouth like an elephant's trunk with a claw at the tip, and it fed on small worms in the seabed burrows. It is ironic that Anomalocaris and Opabinia belonged to the same class, the class Dinocarida. If it were alive today, it surely would be the darling of the aquarium world. An even stranger creature is the hallucigenia. It was ridiculed in the comic Forbidden Giant. Who would have thought that this thing actually existed 530 million years ago? The hallucigenia was only 2 centimeters long. When it was first discovered, paleontologists even got its top, bottom, front, and back mixed up. It took half a century of research to find its head. It turned out that the spines on its back were for defense, and the 7 pairs of feet were used to walk on the seabed. It was like a monster seen in a hallucination. The other little sea worms almost had no fighting power. The Wiwaxia, covered in spines, crawled on the seabed. The ancestors of brachiopods, the Nectaris, drifted in the ocean. Small shrimp, morella, and Yohoia became delicious food. The Orthroxanklus and Pomatrum ambushed on the seabed. They trembled, living precariously in the brutal stillness. It is worth mentioning the giant in the history of life's evolution. The earliest vertebrate, the Haiku-ichthyes, had already appeared.
They were small and weak, with no heavy armor. A notochord grew on their back, allowing them to face the world with flexibility. Maybe they saw everything clearly and chose to go lightly, shedding their armor and skin, evolving a brain, and taking that central spinal cord to lead vertebrates on a long evolution from headless to headed, from ocean to land, from oviparous to viviparous. In the near future, they will stand at the center of the stage. The Ordovician period was another major biological radiation event after the Cambrian explosion. 480 million years ago, human ancestors were still eating mud on the seabed. The thing they thought about most every day was how to avoid being hunted by large carnivores. Other marine organisms faced the same problem. They began to explore a wider sea area, and a climax of life's evolution officially began. The carbon dioxide content in the Ordovician was 10 times that of today. The strong greenhouse effect melted the ice caps at both poles. The vast ocean was unprecedented, and organisms began to reproduce wantonly. Compared with the Cambrian, the size of animals in the Ordovician increased by 3 times, and the number of phyla increased by 4 times. Invertebrates flourished, fish evolution got on the right track, and marine life was unprecedentedly prosperous. At this time, although the land was covered with moss, it was still desolate. The life and death struggle under the sea was happening all the time. The cephalopods had already knocked the overlord Anomalocaris off its horse and stood at the top of the food chain. The giant cephalopod was conical, reaching 6 to 10 meters, like an octopus stuffed into a bullhorn. The huge mouth had teeth that could easily crush food. Tentacles grew around the mouth. It moved by constantly sucking and jetting water in pulse-like motions. It's hard to imagine that such a big and clumsy animal would become a top predator. In the Ordovician, trilobites still lurked on the seabed, feeding on weak plankton, and stubbornly evolved their carapaces, even growing many spines. At the same time, arthropods became larger and stronger, and their internal structures became more complex, making them the most important benthic organisms of the time. The bizarre-looking conodont had a large face with bright eyes and sharp teeth. Scientists, through fossils, have speculated that it was a fierce predator similar to the modern Westman, and it may have been the earliest poisonous animal. The grapholites, drifting in the waves, looked very boring. Some were rooted in the seabed, and some just floated, filtering suspended organisms with their tentacles. Maybe it was because they were unappetizing or had a strong reproductive ability that they became the standard fossils of the Ordovician. Human ancestors were not to be outdone and evolved into the Ignatha, a type of jawless fish. Facing the fierce cephalopods and arthropods, they had no choice but to put on heavy armor and huddle in the seabed. Their clumsy bodies could only feed on plankton and animal carcasses. To survive, they endured humiliation and waited for the dawn. After 40 million years of rise, the Earth ushered in the Ordovician extinction event. This was the first mass extinction in Earth's history. 85% of all species disappeared forever. There are many theories about this extinction event, including gamma-ray bursts, volcanic eruptions, and plate movements. But the root cause is the change in environment and climate. Extinction is a process, not one or two events. 450 million years ago, due to the sharp drop in greenhouse gases in the atmosphere, the Earth entered a short but intense ice age. Glaciers caused a rapid drop in sea level, and the sea temperature dropped rapidly, leading to the death of a large number of organisms. 200,000 years later, the temperature rose quickly, the glaciers melted, the sea level rose rapidly, and a lack of oxygen in the ocean once again caused an extinction event. As the saying goes, survival of the fittest. Every mass extinction releases more opportunities. The survivors of the Ordovician will step on the bones of cephalopods and rebuild the epic of life's evolution in the dwindling ocean, entering the next climax. The Silurian period, a period with little sense of presence, began 440 million years ago and lasted for 2.5 million years. There was no big explosion of life and no tragic mass extinction. but it took an entire period to heal the wounds of the Ordovician mass extinction, nurturing a great transformation.
In fact, the Earth during the Silurian period was like this. The supercontinent Gondwana was gathered in the southern hemisphere, and the continent of Euramerica had just formed. The violent plate collision led to the Caledonian orogeny. At this time, the Earth's temperature rose and the glaciers melted. Plankton reproduced in large numbers, and extensive coral reefs formed, laying the foundation for the appearance of large animals. The trilobites of the Cambrian had already declined. The overlord of the Ordovician, the cephalopod, was downed and out. The arthropods and eurypterids, sea scorpions, ruled the ocean. This strange creature that looked like a scorpion could reach up to 2.5 meters in length, was covered in armor, and had two huge spiny appendages on its front limbs. At the same time, it had a spiny tail that could inject venom. Waving its steel claws, the eurypterid could devour everything, even its own kind, in cannibalism. Fish finally got their chance in the Silurian. Vertebrates finally got on the right track, evolving a movable jaw, and were about to rule the ocean. Small arthropods were beaten without a fight by the eurypterids and turned their attention to the land. At this time, the land was already occupied by moss plants. After repeated cycles of dry and wet, the terrestrial plants gradually evolved a vascular tissue. It not only supported the stems of the plants, but also transported water and nutrients. Pteridophytes took the stage of terrestrial history. After the rise of large plants, the carbon dioxide content in the atmosphere gradually decreased. Scorpions, spiders, and centipedes became the masters of the rainforest. More than 4 billion years after the formation of the Earth, the land was finally no longer desolate. By the end of the Silurian, the level of biodiversity finally reached the peak of the Ordovician period. After a rest, life will continue to move forward. An epic evolution of 400 million years officially began. The Devonian period was a major leap in the history of life's evolution. 421 million years ago, fish, with a central notochord, dominated the ocean. Organisms migrated to the land on a large scale. Amphibious animals appeared. Lycopods and fern plants covered the earth. Arthropod insects spread throughout the forests. A carnival of life officially began. Under the influence of the Variscan orogeny, global plate movements were very intense. The supercontinent Euramerica formed and gradually approached the southern continent of Gondwana. The supercontinent Pangaea was already taking shape. The Devonian Ocean was a paradise for vertebrates. Fish showed a high degree of diversification. Jawed fish rose rapidly. They beat the former overlord, the eurypterid, until it was bruised and battered and forced the jawless fish into a corner. Jawed fish were divided into placoderms, bony fish, cartilaginous fish, and lobe-finned fish. The representative of the placoderms is the famous Dunkleosteus, the top predator in the Devonian Ocean. Its maximum length exceeded 6 meters, and its weight was 1.5 tons. Its head and neck were covered with huge, thick armor. This is also the reason why its fossils only consist of the head and neck. But the Dunkleosteus did not have true teeth. The teeth of its upper and lower jaws were just part of the skull armor. Its bite force was an astonishing 750 kilograms, and it could easily crush the hard shells of ammonites and trilobites. The Dunkleosteus not only used its amazing bite force on its prey, but also engaged in cannibalism. It was brave and invincible, dominating the Devonian Ocean. Bony fish are the most prosperous group of vertebrates today. They evolved a swim bladder. By controlling the air in the swim bladder, they could float up and down. Some bony fish even evolved a swim bladder that had the function of a lung, becoming a transition organ between gills and lungs. Cartilaginous fish also evolved into numerous groups, including sharks, rays, and chimeras, which have continued to this day, showing their strong vitality. The most representative shark in the Devonian period was the Stethocanthus. The male had a bizarre fin-like object on his back.
They appeared in the Silurian, flourished in the Devonian, and went extinct in the Permian. They had a streamlined body with scales and breathed with gills. In addition to the prosperity of fish, the Devonian ocean was a kaleidoscope. The former overlords, the arthropods, were pinned to the seabed by the vertebrate fish. Trilobites evolved a heavy armor and were covered in sharp spines. Mollusks, ammonites, and belemnites reached their peak. The arthropods developed rapidly. Extensive coral reef systems had formed stable bodies of water, and the rich ocean laid the foundation for the rapid development of organisms. At this time, the land was no longer just simple moss and pteridophytes. The lycopods and vascular plants developed further. True fern plants grew into towering trees, several to more than 10 meters tall. The earliest gymnosperms appeared. Forests formed quickly, and the soil and atmospheric composition were optimized. Terrestrial life began to bud. As the earliest arthropods to land, they certainly could not miss this opportunity. They became the first overlords of the rainforest. Brand new arthropod insects also appeared in the Devonian. In the late Devonian, the amphibious Tiktaalik landed on the ground for the first time, achieving a leap in the history of life's evolution. Vertebrates crawled towards the spotlight, evolving more advanced species on this journey. The Panderichthys is the ancestor of all tetrapod vertebrates, including humans. The long river of life's evolution is destined to be bumpy. In the late Devonian, volcanic eruptions, asteroid impacts, and the great prosperity of plants, as well as violent environmental changes, caused several mass extinction events. 70% of all species completely disappeared. All prosperity returned to silence. But the brave Tiktaalik and the vertebrate ancestor Panderichthys, with the halo of evolution, were extraordinarily brave. The desolate Earth was about to usher in new masters. The Carboniferous period began 350 million years ago and lasted for 600,000 years. It formed most of the world's coal reserves. Giant insects were everywhere. It was called the Age of Giant Insects. The marine life of the Carboniferous began to decline. The giant fish completely disappeared and were replaced by crisscrossing freshwater rivers. Rich, sprawling swamps were full of towering plants that covered the sky and the sun. Terrestrial life developed rapidly. The continents of the Carboniferous were actually like this. The continents of Euramica and Gondwana collided, forming the supercontinent Pangaea. The large-scale sea retreat increased the land area. Under the intense cutting of freshwater rivers, a large amount of sediment clogged the river channels, forming fertile swamps. To compete for sunlight, plants became taller. Fern plants occupied the space at the bottom of the forest. Gymnosperms like cycads and conifers towered into the clouds, covering the sky and the sun. A large amount of plant debris piled up like mountains. Millions of years later, they formed coal. In the Industrial Revolution, they returned to the carbon cycle of the biosphere. Time is pulled back to the Carboniferous. The oxygen concentration in the atmosphere soared to 35%, the highest value in Earth's history. Under the protection of the land and forest, countless lives began to reproduce wantonly. The giant Pulmonus scorpius was 70 centimeters long, the size of a small dog. It was a descendant of the marine Euripedids. It fed on spiders, insects, and myriapods. Its deadly venom put it at the top of the food chain. The Arthroplura, a millipede, was up to 3 meters long, covered in armor, and had huge mandibles. It was the largest terrestrial arthropod in history. Can you believe it? It ate grass. It also sometimes ate animal carcasses. The star creature of the Carboniferous was none other than the Meganeura. Its appearance was no different than modern dragonflies, but its wingspan exceeded 1 meter, and it shuttled through the 30 to 40 meter tall jungle. Scientists have not yet found the reason why it had such huge wings. The Rhizodus was the king of freshwater. It belonged to the class Actinopterygii, the ray-finned fish. The longest could reach 7 meters, and its weight exceeded 2 tons. It was the largest carnivorous fish in freshwater. It had excellent vision and strong muscles.
It would attack any animal that got in its way while it traveled through the turbid rivers and swamps, including fish and amphibians. Amphibians, represented by the Ariops, could reach 2 meters in length. The head was very large, and the limbs were thick but clumsy. It was similar to a modern crocodile, frequenting freshwater rivers, lakes, and swamps, and feeding on fish and small reptiles. In the late Carboniferous, the reptile Hylonomus, which had an amniotic structure, completely broke free from the constraints of water. Although it was only 20 centimeters long, it was a fossil vertebrate. Compared to the bustling land, the ocean was a bit desolate. Bioreefs and arthropods entered a slump. Bivalves began to appear in freshwater. The eurypterids were beaten to a pulp by the jawed fish and could only shrink in size and hide in the swamps. Large fish and jawless fish basically disappeared. Cartilaginous fish and bony fish quickly replenished their numbers. The Falcatus shark became the top predator in the waters of the Carboniferous. Extinction and rebirth go in cycles. The laws of nature cannot be violated. In the late Carboniferous, the Earth began to be turbulent. The scale of the glaciers grew day by day. The sea level dropped, and the oxygen content in the ocean rose sharply. The Earth became extremely dry. Volcanic eruptions, lightning, and sun exposure would plunge the rainforest into a fiery haze. The rainforest rapidly shrank. Under the baptism of fire and drought, the flourishing rainforest system completely declined. This event is historically known as the Carboniferous Rainforest Collapse. The eruption of a supervolcano and the melting of permafrost released carbon dioxide that had accumulated for tens of millions of years. The giant insects fell. The surviving organisms embarked on the path of miniaturization, beginning another game of power. The Permian period, the last epoch of the Paleozoic era, was the age of monstrous beasts. After 240 million years of long evolution, reptiles dominated the land and sharks dominated the ocean. But all this was just an illusion. The Permian began 300 million years ago and lasted for 50 million years. At that time, the northern continent of Laurasia and the southern continent of Gondwana collided and combined to form the supercontinent Pangaea. They divided the ocean in two. The one surrounded by the continents was called the Paleotethys Sea. The other vast ocean was called the Panthalassa. Compared with the vast Panthalassa, the environment of the Paleotethys Sea was unique. It was surrounded by continents with well-developed continental shelves, and continental rivers continuously poured organic matter into it. The confluence of ocean currents created this breeding ground, building a colorful and splendid marine world. In the ocean, cartilaginous sharks reigned supreme. The most representative shark of the Permian was the Helicioprion. Its sci-fi appearance was stunning. The spiral tooth fossils are the only evidence it left behind. This posed a huge problem for paleontologists. To restore it, scientists placed the spiral teeth on its head, navel, and tail. Finally, through CT technology, they figured out that this spiral tooth was on its forehead, like a razor-sharp chainsaw. This also made it a fanatical enthusiast of soft-bodied marine creatures. In addition to the top predator, the shark, plankton and coral reefs reproduced in large numbers, decorating the continental shelf with a riot of colors. Myriapods, sea lilies, and bivalves were at their peak. Ammonites, crustaceans, and small bony fish swam wantonly. You could even find the figures of ancient trilobites and eurypterids. The vast Permian continent was unprecedented. Towering mountains blocked the moist airflow. The dry climate caused the collapse of lycopods, ferns, and rainforests. Gymnosperms like conifers, cycads, and gingos rose strongly. At this time, the land was a paradise for reptiles. They were completely freed from their dependence on water. They were divided into synapsida and diapsida. In simple terms, the synapsida were called beasts and were the ancestors of mammals. The diapsida were called dragons and were the ancestors of dinosaurs and crocodiles. Of course, a small number of dragons also belonged to the synapsida class, such as the Dimetrodon. The Dimetrodon is a representative of the synapsida. and was the top predator in the early Permian. It was named for having 2 different shapes of teeth. It could reach 3.5 meters in length and had a 1-meter-tall sail on its back, which could be used to absorb heat and for courtship during mating season. Its limbs were clumsy and it walked like a lizard. The Gorgonops, also belonging to the Synapsida, was a proto-mammal and the top predator in the late Permian. It could reach up to 4.5 meters in length. Its limbs were straight under its body, its muscles were strong, and its teeth were sharp. The canines could reach 15 centimeters, and it fed on diapsida creatures like the Scutosaurus. It can be said that the ancestors of mammals once used the ancestors of dinosaurs as food. The Synapsida also had a little goodie, the Lystrosaurus. It was 1 meter long, looked a bit like a pig and a bit like a hippo. It fed on plants and only knew how to dig burrows and hide in them. It was precisely because of its timid nature that it escaped the Permian mass extinction. In the Permian, the Diapsida were very weak. Represented by the Scutosaurus, it could reach 3.5 meters in length, was covered in thick armor, fed on plants, and became the prey of the giant Synapsida. The Permian began with cold prosperity and ended with hot destruction. The Siberian superplume eruption caused the torrent of evolution to suddenly hit a wall. In this disaster, 75% of terrestrial animals and 96% of marine life extinguished. It was the most tragic mass extinction event in Earth's history. A very small number of survivors struggled, roared, and stood blankly on the ruins, waiting for the next verdict of fate.